Hey everyone, my name is Praveen. I'm originally from Chennai, India, currently living and working in London as a full stack JavaScript specialist, director of engineering, and also a YouTuber. And I have been one day MLH coach, and then I was also awarded a Microsoft MVP. And hey, get me one more again. So apart from these things, I love attending hackathons, meetups, and also answer a lot of questions in Stack Overflow. That's me. And without further delay, so what are we doing today? So first thing is, basically, what is my motivation for creating a client-side encryption? So basically, if you are looking at any kind of encryption, it definitely needs a authentication server, and you need a strong authentication algorithm, and we have seen a lot of different things. But why client-side? There are like lots and lots of reasons. Number one, you cannot have the man-in-the-middle attack because everything gets compiled and executed in the client side, so no one can actually touch it. And another thing is, since the whole content is sent over there, the complete process is happening in JavaScript, so you don't really require a web server as such. For example, a lot of people are not in a position to get a backend server, GitHub pages, Surge, Netlify, and the list goes on. Everything is static site generator, static site hosting engines where you cannot have a backend mechanism there. So to implement that, we are using this one. So this is what is my proposal. But what is the use case? So I usually work with a lot of students, and the students are being given a lot of opportunities to work on different technologies and other things. But when it comes to serverless or backend application, like for example, recently Heroku also closed their free tier. Even though we have got Railway and Cyclic, and there is another thing which starts with again R, render.com, etc., which actually help them to do the backend things, it is a bit complicated. So what if we do something on the client side for one specific use case like verification and validation? So basically, let's say if you want to, let's talk about validation. A lot of students right now are very much interested in getting their swags delivered. This is one of the real use case which I'm talking about. A lot of students are looking for their swags delivered to their homes, but there is a bit of a risk in displaying their public information, right? So address, email address, phone number, etc. Everything is very sensitive. So what if we give them a password that they know, and we do a double salting or double hashing? Okay, this is the thing which I wanted to talk about, so I'm not, just forget what I said. So if we do any kind of mechanism to give the complete content of the message on the public, but at the same time it is encrypted in such a way that you cannot use brute force attack, or literally you cannot do anything in that case. I mean, anyway, if there is a security, it is bound to break. Even Okta will say the same thing, I believe. But we are just putting a lot of hurdles in this case. And when it comes to client side, it is even more easier. So this is like one of my simple way of representing something. But I'm happy to even put a really hard, a really good amount of sensitive information as well. And so what do we know already so far? We have seen a lot of algorithms, like this is triple DES, then we have Blowfish, we have AES algorithms, we have got some crazy algorithms too, private key, public key, RSA, etc. But if we see the current practice, what we have got is, so we get the username and password, and the password is being converted into a hash. So the difference between a hash and encryption is, hash is one way. So once you convert it into a hash and store it in a database or somewhere in the backend, it cannot be used to retrieve the original thing. But recent times with machine learning and cloud computing, and even the artificial intelligence like GPT-4 that can literally look at a lot of data, we are able to see sites like Hashkiller and other things where if you put the MD5 hash or anything, it is able to retrieve the original password as well. So what if, okay, this is going to be my proposal here. So you still have the plain text, but we are using the same plain text as the salt as well here. So if we have both plain text and salt, and give it to the encryption function. Whatever we are using is like you have a simple encryption function that takes in a salt and a text, and basically what happens in all these cases is, let it be your average website where it is asking for your username and password. Since MD5 hashing is the worst thing ever in terms of security, they use another salt, but that salt will be same for you, me, and everyone else, right? So what if your password is the salt for the password as well? So both the passwords are the same, and the encryption function creates another password that we will be using as the key to encrypt more data and then display to that particular user. So this is what is my proposal. So basically we will just go ahead and code. If you have your laptops, you can actually take it, but let me try my best to keep this and code as well. Okay, so the first thing that we are going to do is we are going to see a simple salt based encryption and decryption. I've got, okay, so there is, in simple terms, there is a lot of garbage here, that's it. So you don't need to actually look at this code even, because this is a code that I just randomly searched in Stack Overflow and got one of the best encryption codes. So let's see how it actually works. So I'm gonna go down here. So this is our main thing, okay? So we have got two functions. One is the crypt and another thing is the decrypt. So crypt function will try to take the plain text and convert it into the crazy text. And then decrypt will take the crazy text along with the salt and then gets the plain text. So this is what it happens. And if I try to run this code here, you'll be able to see that I have given hello world as the plain text, and after it goes through the encryption with the salt as hello plus hello world, it gives you a text like 2A272E2. It looks like some kind of like what should I say, hexadecimal code. Let me try to change the hello world to something like hello JavaScript, because that seems to be very small with some numbers. And then if I try to run this again, so I could probably see hello JavaScript 56 with, yeah, I don't see anything that is other than A or B, which is interesting. So it converts it into a encrypted form, but it is easily, you can decrypt it. But the fun part is you have to have the salt, and the way so this is the basic implementation of how this particular salt based encryption works. So now what about different types of values? So we have got a lot of values here, right? So we could pretty much have a look at an email, a phone number, and what about a URL which has got a lot of parameters. We will also go one step higher to see if we can actually use an emoji as well. So these are the things that we are going to try right now. And if I try to run this script, let's see how it goes. So basically it starts with this. When you are having a small at or anything, it seems successful. If you have plus signs, it seems successful again. And we could see maximum E and D, nothing else. And here we are able to see any F, no. So it is, I don't know what kind of an encrypting algorithm it uses, but there is an F, right? Okay, cool. So this is indeed, it's a hexadecimal code. So it's converting it into the hexadecimal value, but it is using something else as well. So it is not just converting the text into hexadecimal, it also uses some kind of a mechanism. And then you're able to get it back. What if I have got a different salt, like the same salt? So I used H2O here, but for the difference of the salt, I have used reverse that O2H or something like that. It should technically fail, right? So probably it failed, which is understood. And the worst part is, what about emojis with color modifiers and other things? So I'm using a Mac, so I'm able to get this emojis with, or we can use WhatsApp or even any of these emoji pickers to get the color modifier and everything. Unfortunately, it is getting decoded like this. So this is one of the downsides of what I have done, or what is this particular encryption algorithm does. So this is the basic stuff. So it is able to encrypt and decrypt most of the values that we generally want to use. So what about a complete implementation? So I've got this particular script here. So basically what I have done here is, let me try to increase the font size. Okay, I'll explain the whole code quickly, and then I'll try to tell you what exactly I have done here. So first thing is, like, I have defined both the crypt and decrypt functions. Then I'm expecting a password from the user as a prompt. So this could be considered as a real implementation. And then in case if the password is not given, we are going to say that, okay, technically I added something very bad here, but I have just changed it into welcome to meetup. So the next thing is, if whatever the password that you are giving me, I'm going to encrypt the password with the same password as the salt. So I'm going to take the password which is given by the user and try to convert it into an encrypted one using the same password. And then I used to get a huge hexadecimal value or something, right? So I'm using that value here to check if whatever the password that I have given is right. If that is the case, you still have a lot of things to decode here. So these are the encrypted values. So I know the password is my name here. So what I'm going to do here is, I'm going to just try rerunning the code. So it is going to ask me for my password. I'm going to put my password, which is Praveen, and then boom. So it gives my card number. So if everyone knows that this is the Stripe's default sandbox card number, and that is what I have encrypted here. I'm going to put this code infinitely in public, but if someone is able to decrypt this, but you know what, we can always change the password, we can change the encryption algorithms, everything can be changed. So this is the thing which I was trying to propose, and this is, where does this help, where will this be helpful? So I'll talk about the use cases in a few minutes. Before that, I wanted to also tell, this is not always a foolproof one. For example, yeah, so this is a simple thing, like if you're not giving the password, it is going to say welcome to meetup, and if you're going to give a wrong password, obviously it is going to not decrypt and tell something else. So access to this information is denied. So basically this is the code, very simple one. Everything has been uploaded on GitHub, so I'll give the access very soon. So this is the current complete implementation. So if you want the code, here's the code. Grab it. And please let me know if this works, because I just did it on the fly at the end with all these snakes and ladders. Is it working? So if I have a look at the bugs, one of the things that I wanted to see is, I don't know exactly where exactly I kept the bugs now. Oh yeah, it is the third one. In this case, what I have given is, I've given the salt as hello, such a simple salt, but what if I use the salt hello with different cases and then try to run it? That is when the problem comes up. So basically, if you could see this, if you are not giving the password in the case insensitive manner, you are technically leaking out the information, but at the same time, since we have a different way of taking the password in and verifying it with the hash, this will be avoided. But still, if you know the password, even if it is case insensitive, you are able to get it, which we can kind of prevent. So this is one of the issues that I have seen in this. And finally, coming back to what we are working on. So that was the complete presentation.
It seems that when you use different length of password, you're also leaking, like the salt is also leaking. So when you use the short password, you'd get
A short number of, yes, you are kind of giving out what could be the password length, which is fine, but still, okay. If the password, I mean, like it is a general practice in almost all the companies and everywhere. I know it could be not right for the unaware people. We can actually limit people telling like, hey, make sure you are having 16 character password as minimum. That is the basic rule. Something like that. We can impose those kind of things so that even for accessing the system, this particular, you are right, what you said is perfect. 16 character minimum or 10 character minimum, even 7 character minimum. We can use some kind of things. Thanks, that's a great idea, and I'm going to implement that in this one. And I would also like to know what is your feedback on this kind of a thing, because I still haven't said what is the exact use case that we are using. Yeah, go on.
As I understand, this approach of server-side encryption is to get to use an application and add some security, which is run in the client side without a server. But what would happen if the user, instead of trying to guess the password or do anything else, just by editing the code of the page, completely removes the security part, the login, and
But still, you need to have the, because your username and password is the, or maybe your password is the key to decrypt. So you cannot technically, what you said is right. The source code will be public because it is on the client side. I don't need to give any protection. Whatever you saw in the code pen, it is going to be on top, like, yeah. So this is going to be public. These two strings are going to be public. But what could you do with this? It is not possible to do anything with this unless and until you know the decryption key and the decryption algorithm as well. Thank you. And one more thing, that was actually a great question, but where are we using these things? Like, where am I using this personally? So there was this particular hackathon which happened a couple of days ago, and they wanted to see if their details have been successfully stored. That is one thing. So they wanted to make sure that whether my personal details have been received by us as the organizers, and also they wanted to tell the employers that we have got this particular we prize or we won here. So if you want to go ahead and verify it, give these 3 details to this particular website. But we have hosted the website on a GitHub pages, where in case if you are putting your username, it is going to redirect to the username.html. And then in that, if you are adding those passwords, it will decrypt whatever is contained in it. So we just made a simple node.js application, a command line application, to generate all the HTMLs based on that, along with sending these two, let's say here it is card details and URL. Similarly, we have added all these things there. So even though it is not a hypersensitive information or sensitive information, we just made use of the client side code. And the main thing that we can avoid is, like, you can avoid scraping of data. That is one thing. And another thing is, like, it is, to an extent, it is protected. It cannot be random. You don't see the diamond literally on the mountain, but it is actually covered somewhere, something like that.
Have you heard about like WebRTC?
Yes.
So, like, for those of you who don't know, WebRTC basically allows you to create a peer-to-peer connection between 2 different devices, which means that you can connect like one laptop with other laptop without having a server in between. So potentially what you use can be, what you created can be used like to like encrypt and decrypt some details.
Okay.
Like, does that make sense? Or like,
That makes,
do you think that that can be possibly used?
that is one of the possibilities, but there is also an answer for that. Personally, my mission, I have actually messed up with the WebRTC. So any WebRTC enabled thing, for example, let it be Discord or let it be Google Hangouts or Other than Zoom, nothing else works, because other than Zoom, everything uses WebRTC connection. And the moment I open anything, like even if I want to play around with WebRTC, I was not able to do it. But yes, this is one of the options as well. But if you are trying to produce mass verification for the exact use case that we did not have any kind of resources like a storage or server. At that point of time, we just used GitHub pages, and we were able to secure a lot of details, and they were also all of the students were also be able to validate the content, so something like that. So for small things, which is, I mean, I won't recommend, as a security loving professional, I won't recommend putting any sensitive information, but at the same time, I would say that this works.
Just wanted to add a note that it's not very secure. So one of the reasons we don't do client-side encryption in general is that the client-side code is debuggable by the end user. Like if I have access to the Chrome browser, I can just right-click debug tools and I can see code as it executes. And if I know how the decrypt function works, because the decrypt function is something that you have written in JavaScript, you're not using like a node crypto API or something. So it's not abstracted away from me. So the first reason we want to encrypt on the server and not the client is just the fact that the runtime code access is available, and somebody can look at the VM and look at the memory locations and actually see what is happening so that they can replicate it or reverse engineer it, which is why we don't do it. So I think it's an interesting idea, so but not very secure.
I totally agree with you, but there is one key thing that you forgot. Whatever the password or whatever the code that you are giving is the instruction to how to decrypt, right? So you don't have that part.
Function is still written, right? So this
Decrypt function is there. The decrypt function needs another part.
There's an input to a function, right?
Yes.
So I can just send so many inputs to the same.
Exactly. You are talking about brute force algorithm. I told you like any security can be broken. So
Not as easily as this.
not as easy as this. That's true.
Very, very small. But the idea is nice. So this is actually, it has a term. It's like a self-encrypting plain text. So this is like, can be used in many other ways.
Thank you. And a lot of my colleagues and other people have also told about double encryption, double lock, and self-encryption. And also there is one more thing. Yeah, it was almost similar to public key encryption, but I don't see how it is similar to PKCS. But that was a great learning. Thank you. Self-encryption, I'll have a look at it.
Right, perfect. Praveen, thank you very much for coming and joining us here at Auth0 offices, and nice.